Welcome to Study Loop.
This is the answer to Chapter 14, problem number 7 from the Smith Organic Chemistry textbook. And this problem asks us which proton or protons in each of these molecules, so which of the indicated proton or protons in each of these molecules is going to absorb further downfield. And so this question is really asking us about de-shielding. And so hopefully you remember from the text that de-shielding refers to electron density being withdrawn. And so protons that are on a carbon that is directly bound to an electronegative atom are going to experience this de-shielding effect. And so when we look at A, we have protons on a carbon that is bound to a fluorine, and we're comparing them to protons on a carbon that is bound to a chlorine. And so fluorine is significantly more electronegative than chlorine is, and so it is going to exert a greater de-shielding effect. And remember, the more de-shielded a proton is, the further downfield it will absorb. And so these protons here that I'm arrowing in green are going to absorb further downfield because of the de-shielding. Okay, and so looking at B, so this time we're comparing methylene protons that are on a carbon that is bound to a methyl group and another methylene group. And we're comparing methylene protons, we're comparing those to another set of methylene protons that are bound to another methylene group, but then they're also bound to an oxygen. And so oxygen is electronegative, and so it's going to exert a de-shielding effect here. And so these protons will be much more de-shielded, and therefore they'll absorb further downfield, probably significantly further downfield. So maybe several ppms to the left. And so then looking at C, we're actually making a very similar comparison to the comparison that we're making in B. So we're comparing protons of a methyl group that is bound directly to oxygen, and then protons on methyl groups that are one carbon away from the oxygen. And so the closer that these protons are to the oxygen, the more they're going to be de-shielded. And so these protons should be significantly more de-shielded than the other protons in part C here. And so they should absorb somewhat significantly further downfield. And so that's the way to solve this problem. We just need to remember that electronegative atoms are going to exert a de-shielding effect on protons to which they're near, and that the closer the electronegative atom is, the greater the de-shielding effect is going to be. And the more de-shielded a proton is, the further downfield it's going to show. And so that's the answer to Chapter 14, problem number 7.